we've highlighted a couple basic properties of this universe, inescapable properties, finite resources, and change continues. So what happens because of those? Well, we've introduced some ideas. So one is very simple, that there is a competence envelope. So we'll just draw a box, right? That there is an envelope within which we have a system, right? A region of a network of actors and capabilities and how they work together to accomplish goals, right? Carry out missions, provide valued services to a variety of stakeholders. Now, because of finite resources, there's a limit, there's a boundary. So that's our competence envelope. Now, what happens though is there's an area around this because we don't know exactly where it is. And even if we think we know where it is, it's probably different. And by the way, we think of it as being a fixed boundary, when in fact it's dynamic, changing, and moving. Right? The world keeps changing, others keep adapting to our successes. So this capability, this competence that this envelope marks out still has limits. There are still challenges that arise and surprises that occur, and that still requires extensibility. So out here is in these borderlands, what's going on are some of these hidden sources of extensibility that often we miss and don't see because of the fluency law. We are seeing surprises and challenge events recur, smaller and larger. Given finite resources, given the kinds of trade-offs we have to make, there are going to be instances that arise that challenge these boundaries. So we can start to think about this as, right, actually on an axis of growth, right? This provides capability, which creates growth. That's the third point we started with. Others are adapting to our success. So that will also influence the surprises, challenges, the sources of extensibility or constraints on those sources of extensibility. Now, wait a minute though. We really need to step back and say, hey, wait a minute, there's time. Right? And as we put time in, right, we're indicating there's a process of development. So in reality, this competence envelope at some stage is a reflection of a previous process of growth, right? That we had a previous competence envelope and we inserted some kind of new technological capability or other forms of capability that might accompany new technological capabilities, such as we've reorganized, we've developed new organizational structures, new relationships, new functions, new groups that support those functions. Things we'll see when we go through the rise of high-frequency trading in the financial world. So this tech thing created an improvement because we were somewhere that had its own competence envelope, that existed with its own borderlands of challenge and surprise and extensibility. And that became the inadequacies, the limits, other things led to an opportunity to say, let's improve that relative to these, and we create a new system. So we're operating on a dimension of growth. Now, the usual assumption, though, is that with growth, we just keep getting better, which implies the borderlands shrink. The surprises weaken. They may occur less often. We see them as rare. We start to assume that the competence envelope just grows and grows. Instead, changing the competence envelope stimulates growth, stimulates change, stimulates others to seek advantage, right? And exists in a world where we had to make trade-offs because of the finite resources. Ultimately, those trade-offs are the fundamental ones that characterize this universe, not just the pragmatic ones we had to solve in any particular development project, which we then deployed into the world. So what's happening on this dimension is a process of complexification. That's hard to say, complexification. But it may be easier to say growth is accompanied by complexity penalties. It's natural in growth for scales to increase, for interdependencies to grow. Therefore, when things go wrong, the effects, the disturbances can propagate faster across these lines of interdependencies. It creates effects at a distance that make it harder to diagnose and understand what's going on when a disruption occurs, an anomaly starts to undermine the function of the system and the system's performance starts to deteriorate. So these effects are complexity penalties that accompany inevitably growth. We want growth. That's success. That's what we're marking out. Complexity penalties go along. What that means is we need to think deeper about the architecture of how we support growth with extensibility. And graceful extensibility then becomes a key ingredient so that we have viability in the face of complexity penalties as our new developments stimulate growth. So let's go through what we've sketched again and build on it. So we started with, over time, we have developments. We have a competence envelope, that's increasing in competence, increasing in reliability, yet there is still a boundary. There is still uncertainty about where the boundary is and how it changes. There are still challenges that arise, surprises. There has to be extensibility. And those all operate in these borderlands around the competence that we've developed by inserting new capabilities. And that continues. And again, when we insert new capabilities, deploy them out into the world, it happens again because finite resources are still operating, trade-offs are still fundamental, change is still continuing. And this process of development stimulates growth, stimulates complexification. So the system is now operating at new scales, new kinds of connectivity. And this leads us to more extensive interdependencies, which become hidden paths for trouble to develop in new ways. So we have scale, growth, complexification. So what do we understand about this? We now understand, right, that graceful extensibility is essential. Viability in the longer run requires extensibility. That is a hard constraint on this universe. It's a universal property. Somewhere there has to be sources that can produce extensibility because the boundaries will matter and how we think we know where they are and what that means will be surprised. The model we have of competence will be surprised by the world, by the finite resources, by the limits of the way we made trade-offs, and by the way other actors and agents will adapt to take advantage of the new developments and competencies that we've injected into the world. Now, we can use this line as kind of a diagonal dividing line and say we can think about this process in terms of the fundamental science. Now, what happens here is these are the laws that govern how adaptive systems work, regardless of the scale or type, whether we're talking about viruses and cells and cardiovascular systems, our bone system, which turns out to be quite a dynamic system too, as you'll see in one of the videos you'll watch. Or moving up into systems that handle energy or hospital systems that deliver care to injured and sick people. Regardless of the scale, there are laws that govern how adaptive systems work. And that's the science side. But the science side is there in order to drive pragmatic action. How can we architect systems so they can demonstrate graceful extensibility? Because graceful extensibility has to be provisioned in this universe, which is also subject to the constraints of the laws that govern adaptive systems and those fundamental constraints we started with of finite resources, continuing change. So the science has developed by studying how people in various roles and various kinds of systems and sectors adapt to cope with complexity. Why do we study people? Because they're inherently adaptive. And so we see patterns in how people adapt. So we observe, right? We discover and abstract the patterns that go on. From those, we can create laws, because these are regularities that occur over and over again in different situations, right? And eventually we have theorems. Theorems, laws, patterns. That's on the science side. On the pragmatic side, we have to say, how do we build and sustain adaptive capacity over cycles of change? Here, we're interested in the co-adapting, right? How do we insert something that will stimulate others to adapt in ways that will have the right properties that we wanted on the science side? Now, we'll talk about this in terms of initiative and reciprocity. Constraints like reciprocity will always be asymmetric, and that's going to make it more difficult to build reciprocity, and why mutual assistance in a network of interdependent roles will be critical. And how do we build and sustain that? How do we make it work if we're dealing with, say, emergency medicine, critical care medicine, an ICU, an emergency room, and surge? When do a lot of patients come in with severe illness or injuries, like in a mass casualty event? So we call these beyond surge capacity events. How do we make it work in the emergency room disaster response, medical side of disaster response? Notice in studying that, in provisioning it with new capabilities, what are we doing? We're observing these interventions, right? And saying what patterns happen, right? So how does that change and modify the laws? Do we see the laws operating? Do we see new regularities about how interventions, right, allow us to achieve what we want given the laws that constrain adaptive behavior? Ultimately, we provide tests of the theorems because the theorems should be guiding the kinds of architectural principles that we're instantiating in particular settings. So we've been developing from our observations and abstracting patterns from these observations, our attempts at intervention in different settings, or to observe the interventions that have gone on to make those systems be able to demonstrate graceful extensibility in the face of stress and challenge that goes outside the range that people had anticipated and planned for. And the progress we've made in recent years has resulted in two comprehensive theories. So the science side, we have two. One comes from John Doyle and his colleagues, called diversity-enabled sweet spots. And we'll look at that, or some of the factors in that, a little bit. Mostly we're going to focus on the other comprehensive theory, the theory of graceful extensibility. We're going to focus on that one mostly because it extends into human systems more directly. And so it can stimulate our understanding of what do we know so far and how we might need to revise that as we learn more. And also, what can we do now? What should we be trying to do in order to make our systems more robust and resilient in the face of stress and challenge? Because that's a practical need our societies, our industries, our organizations need, right, given the challenges, turbulence of the world that we live in today. Now, the science, whether you go with the theories, the comprehensive theories that exist right now, or whether these get modified or we develop new ones, they've identified some things, back to the theorems and laws, right? So the laws are there's limits on robustness, right? So we want to be competent. Part of competent is being reliable. That's a record of development over time. Looking backwards, we're getting more compared to where we were. But in getting better, right, more optimal, more efficient, more productive, whatever those criteria are, we also need to be robust in the face of challenge, disturbances, perturbations that we can model, that we can think about, we can characterize. And so we try to make the system, right, robust in the face of those disturbances. In other words, it will continue to work or degrade gracefully, not have bad consequences, not be brittle at the boundaries, not to have a sudden drop off in performance at the boundaries. But there are limits on robustness, right? And the limits are back to we are not going to be able to characterize everything about the boundary area and what challenges it. Why? Limited resources, trade-offs, and change. As the folk philosopher from baseball in the 1960s, Yogi Berra would say, even if the world were perfect, it wouldn't be. In other words, even if we were successful to narrow this down exactly and tie it down to know exactly the set of perturbations, we would stimulate growth, we would stimulate adaptation, we would stimulate change, right? And that would mean we don't know exactly what's going to be the challenge and how our plans for being robust will be incomplete in the face of those new surprises or the new twists on surprise that occur as growth continues. Scale goes up, interdependencies go up. We see this, and we'll talk more about the world of software, right? And how critical digital services underlie and exemplify all of this. And in fact, on the pragmatic side, they've taken this understanding, they've added to our understanding, and they have been developing pragmatic interventions that allow us to grow the kinds of critical digital services that are valuable to many kinds of stakeholders and that all of us depend on, regardless of what sector we work in, what layer of that sector, what kind of role we're in. We all depend on the infrastructure of critical digital services and the valued services they provide out, but also to each other. And so we'll refer back to that as another sector that illustrates the criticality and development and potential of resilience engineering. From a pattern point of view, the key pattern over here is the risk of brittle collapse. Everything has to include some ability to mitigate brittle collapse. This is why we say that biology abhors competent but brittle systems. Right? Biology says I need to be competent and I need extensibility at the boundaries. I need to have future adaptive capacity. I need two. I need both. And the difficulty is they are not linearly related. They don't simply add up. We do the stuff for this and then the stuff for this, and we get both. No, they interact. They're interdependent. So there's a nonlinear relationship between these. And if I pursue productivity in the short run, and only that, and only prioritize that, and only pressure all the parts of the system to pursue that, I inevitably will undermine the ability to support graceful extensibility. Graceful extensibility is essential, and so it has to be there in some fashion to mitigate the risk of brittleness. The risk of brittleness, the risk of brittle collapse is universal to all systems. The issue is people have some capability in some roles with some support with the right organizational structure to demonstrate graceful extensibility. Our machines do not. Our machines are not designed. Whatever the algorithm, whatever the improvement, it's not designed to try to be extensible at the boundaries because they think they already thought of all the things that would make it robust, right? But their ability to model and understand the world can't keep up with the extent of the world and how that world changes and how that world is constrained by finite resources and how different trade-offs occur and arise. And where you should be in this trade-off space can vary as the context varies, right? And as our situation, as our growth varies. So we need a system that is dynamic in the face of this trade space that has multiple trade-off dimensions. On the pragmatic side, we can talk about a variety of kinds of developments. And over time, we can add more because we'll develop more. And around the world, people are working on this in a variety of ways, posing new challenges on how do we support resilient performance at different scales and different sectors. What are the pragmatics we can deploy in the near term or medium term? One of these is that we need to deconfound reliability, robustness, and resilience. That derives from the science and comes over here. And we can start talking about pragmatic techniques that allow organizations to see that reliability doesn't guarantee robustness and resilience, that investing in robustness does not guarantee resilient performance in the face of surprise and challenge. And that happens because I think it's very easy to understand, and you can watch a video and we'll show you some stuff. And it's all organized around a question Lauren Hochstein, one of the people developing resilience engineering in software, posed for us. Why do reliable systems fail? If they're reliable, shouldn't failures disappear? But remember, we talked about why that assumption that as reliability statistics go up, therefore surprise and challenge should go down and get weaker and rarer. And that's not what we see. We see new forms of challenge and surprise because of the process of complexification that accompanies growth. Now, from a science point of view, we're going to cover a variety of things related to the theorems, the laws, and the patterns. We're going to highlight theorems like perspective bounds. We're going to highlight theorems about how our models are inherently miscalibrated, right? We're going to talk about the locality constraint, that we're always in the network somewhere, right? And we're always able to look out from that position or look around from that position, but we're not able to stand outside. That's a kind of radical reframing of how we normally think about our systems and how we develop and design and deploy systems, because we are outside with a pragmatically omniscient point of view on the system due to our analysis and data. It's not complete, but each time it gets more complete and more optimal, right? So locality, miscalibration, perspective, all become critical ideas that are in the theorems that constrain how the adaptive universe works. We'll talk about how the laws guide certain kinds of general techniques we can use about perspective shifting and perspective contrast and how that can work in different settings. We'll talk about reframing and how that works as a fundamental characteristic. It's a kind of cognitive characteristic. Interestingly, only people have the ability to reframe, even though reframing is very difficult. Think of reframing as sort of kind of the ultimate of revision. And so how reframing works and how reframing can be supported, again, as general findings that could be applied in many different ways as we confront complexity and how maneuver complexity in different sectors at different times. And then we said we have patterns. Well, there's 3 ways adaptive systems break down, and there are 3 ways that adaptive systems overcome those 3 risks of breakdown. So those are the key things that we need to focus on, regardless of what particular world at what particular stage we're dealing with on the pragmatic side. So we can take these science developments and bring them over onto pragmatics as a kind of general guide about what we could do to improve in a particular setting if we have a near-term or medium-term perspective and some resources available to invest, some willingness to consider change in new directions. One of them is related to the perspective and the bounds, the fundamental bounds, trade-offs on perspective. And what that leads us to is a variety of general strategies and tactics we can do to enhance how do you see ahead? How do you see around? How do you see anew? Right? Seeing Seeing ahead, seeing around, and seeing anew are fundamental characteristics that support the adaptive capacity to be able to continue to revise. I mean, that's what this structure we've laid out of science, observation, interventions that sustain adaptive capacity, that build and sustain graceful extensibility, the recognition that graceful extensibility is essential. All of these revolve around those two letters, R-E, revise. It's not how good you've been. We're assuming you're trying to get better and that you have a record of getting better on some criteria. However good you've been, the question is, can you revise? Can you reframe? So how does seeing ahead, seeing around, seeing anew support processes of revision? In these, we then start focusing on the positive side that offsets the three ways adaptive systems break down. So we start talking about how can you keep pace with events? How can you synchronize over multiple roles and layers in order to handle challenges so that the actions of each role, each part, each unit, right, combine with the others in a way that produces a more capable emergent system or emergent neighborhood of capabilities that goes beyond how any of the individual component units can perform given the kinds of trade-off they have to navigate. So they have to be positioned and make some trade-off across those multiple dimensions. So if we balance multiple units in the right way across layers, we can synchronize those activities. Right? Seeing ahead is dependent on seeing where stress is changing and stress is increasing, and we're running out of our capacity to respond to stress. Our capacity for maneuver is being exhausted. Synchronizing is about how we help each other, mutual assistance we provide, reciprocity we provide as we work together. When do we work together? When parts of the system are under increasing or high levels of stress, approaching saturation. And we'll talk more about how saturation is a universal characteristic of any unit and any adaptive unit at any scale, at any layer of the system. And then we have to talk about how we don't get stuck in stale old models. The problem with the getting stuck is it's not that the old models were wrong. They work better. They did provide value. They did provide a way to stimulate growth. But they become stale. That's the key word. Stale. What was once valuable becomes less valuable because it improved. The actions taken on that model produce change and growth, which others adapted to, which produce more change, more complexities. All right. And so now we need to revise our model. So these are the processes of reprioritization and reconfiguration. What's your ability to reprioritize and reconfigure? Again, it starts with RE. Can you revise? Can you reprioritize? Can you reconfigure? When the evidence is building that the system is under increasing and different kinds of stress or sources that are producing stress on the system. Interestingly, our world right now is shouting loud. It is sending vivid signals into the air saying, our world is turbulent. Our world is full of new stresses. Those stresses are increasing in the sizes and occurrence. We can't predict when, where, and how a particular stressor will hit what particular unit or sector. However, we can be quite confident that challenge is increasing in size, scope, difficulty for us to meet. That's why we need resilience engineering and the pragmatics and the fundamental science more than ever.